Hi everyone, today we want to solve this nonlinear equation. If you want to solve the problem yourself, please pause the video now. Okay, so this is another one of those problems that can have an elegant way to solve it, or it can have an elaborate way. So the straightforward way is to calculate the third power of the expressions in parentheses and then simplify the equation and be hopeful that we can solve it. But since this is a third order equation and there is not really a systematic way to solve third order equations that I know, it might be a little bit difficult to solve it. But if we inspect this a little bit more carefully, we can see that it involves the sum of three cubed terms that is 0. So if I want to be a little bit more clear, I can rewrite this as 2x minus 3 to the power of 3 plus minus 3 times x minus 2 to the power of 3, and then minus 3 to the power of 3 will give us minus 27, plus x minus 3 to the power of 3 equals to 0. Now we see that this is sum of three terms that are raised to the power of 3, and that sum is 0. And if we inspect the expressions inside the parentheses, we can see that in fact the sum of these three terms is also 0. So these three terms are 2x minus 3 minus 3x plus 6 plus x minus 3. And therefore 2x will cancel with minus 3x and x, and minus 3 and minus 3 will cancel with 6. So this is also 0. And if you remember from problem 1, and we have been using this identity quite frequently over the past few questions, we have three numbers, a, b, and c, whose sum is 0. So a plus b plus c is 0. And therefore, the sum of the cubes of these three numbers, a cubed plus b cubed plus c cubed, will be equal to 3abc. And now we see that a cubed plus b cubed plus c cubed is also 0 here, which is this term. This is a cubed, this is b cubed, and this is c cubed. Therefore, we can say that 3abc is also 0, and therefore abc is 0, and we get 2x minus 3 times minus 3 x minus 2 times x minus 3 is 0. If the product of three expressions is 0, each of those expressions can be 0 for the product to be 0. So 2x minus 3 might be 0, and therefore x1, which is the first root, can be 3 over 2, or x minus 2 is 0, therefore x2, which is root number 2, is 2, or x minus 3 is 0, which gives us x3, which is the third root, equal to 3. And therefore we solve this equation. So you may ask, how do I know that this equation has only 3 roots? This is a third order equation, and a maximum number of roots that an nth order equation can have is n. So here we found all 3 roots of this equation. In contrast, if we wanted to raise these expressions to the power of 3 and simplify it, the least of it was that we had to do a lot of calculations. So using this identity is kind of an elegant way to solve this problem too. If you like this problem, please consider subscribing to the channel and share this with other people who might be interested. I will be posting more questions at the rate of about 1 question a day, and I would appreciate your feedback. Thank you.